Hey, welcome back. We're moving on to our next intermediate sorting algorithm, which is called quicksort. So it has a bit of a catchier name. It sounds better than merge sort. I mean, who doesn't want a sort that is called quicksort? But I have to admit, personally, this is the bane of my existence as far as sorting algorithms. Not because it's bad. I mean, it's very useful, as we'll see later on. It's efficient. It works well. It is indeed quick. But for some reason, my brain just does not like the way that quicksort works. Anytime I have to teach these sorting algorithms, I usually, like the night before a lecture, will go review, make sure I remember how everything works. I can rewrite the code. And occasionally, I'll have to reference previous code or something. But with quicksort, every single time I have to double check my work. My brain just rejects storing it. It does not like it. So not to poison your opinion of it ahead of time, because I have had many a student who really loves quicksort. Just for me, the way my brain works, it's just not very intuitive. So we're going to pay special attention to trying to understand it and make sure we step through it. Okay, so quicksort, it works on the same assumption that merge sort does. It's one that is going to be easiest to solve through recursion, where we keep basically splitting up the data, the array, until we hit arrays that are 0 or 1 item long, which means that they are individually sorted. We have an item of one, you have an array with 1 item, it is sorted. So that's what we take advantage of, but we do something different. We work by selecting a single element, which we're going to call the pivot point. So in any array, you pick any element. It doesn't actually really matter. We'll talk about some of the implications, but let's say we pick the element in the middle. What we're going to do is move all the numbers that are lower than that number to the left of that number, and all the numbers that are greater than that number to the right. Now, we're not going to sort them all. We're just going to move them to one side. And then from there, we know that that one number is in the correct spot. Only that one number. All the other numbers on the right side of things, or the left side, but we don't know the exact position. So then we repeat the process for the left side and for the right side. So if that explanation made zero sense, I don't blame you. Let's take a look at a little diagram. So if this is our array, we have 8 elements, 1 to 8, the numbers, and they're in a random order. What we do is we just pick some element, and for this example, we're going to pick the first one, which is 5, and then move all the numbers that are less than 5 to the left of it, and all the numbers that are greater than 5 to the right. So if we count the numbers that are less than 5, we have 1, 2, 3, 4 numbers. So that means that we should have 1, 2, 3, 4 here. We're going to move them all here, and then at this index right here, we'll move 5. And then on the right side, we'll have 7, 6, and 8. And if you look at the next step, that's what we've done. So 5 is in the correct spot. We know that in our sorted array, 5 is going to have index of 4. 0, 1, 2, 3, 4. These aren't sorted, this isn't sorted, but this is sorted right now. So now we recursively repeat the process on the left side and the right side. So on the left side, let's just start again. It doesn't really matter what we pick. It will work no matter what. But let's pick the first item again and put that in the correct spot. So that means it's going to be at index of 0, 1, 2, because 1 and 2 need to come before it. And that's what we end up with. So now this is in the correct spot. We know in our final array, 3 is going to have index of 2. 5 is going to have index of 4. Then next, we have an element of 2, or an array of 2 elements. This is nice and easy. So we pick the first element, which is 1, and we figure out where it needs to go. And that all that we have is one other element, which is greater than it. So the right side now becomes 2, and we can sort that, and it's a single element. So we've now hit the end on our left side. And if you kind of look, imagine putting these all on the same line. We end up with the sorted array, at least the left side of the 5. Then we have to get to the right side. So remember, all the way at the beginning, we split right there. We just took care of this. Nope, highlighting the wrong thing. Okay, my computer doesn't want me to highlight that. We took care of the left side here. Now, let's get to the right side. So we pick the pivot point, which is 7 in our example. And we have to figure out, okay, where should 7 go? What's the index where it should end up? We move the other elements. So we move 6 to the left of it, 8 to the right of it, and those are both single element arrays now. And actually, if you look at what we have, 1, 2, 3, 4, 5, 6, 7, 8, we have the sorted array. There, I got ahead of my slides again. I'm always doing that. So This shows us how it works roughly. It makes sense, I think, in a nice little diagram, but when we actually start working and trying to write the recursion and visualize it when we have code, it can be a little bit tricky. Okay, so I have Visual Algo pulled up with Quicksort now. So here's another visualization. We start with this unsorted array and we pick 11 as our first pivot point. So we want to move all the elements that are less than 11 to the left of it and all the ones that are greater to the right. So we start and just compare it. Okay, 40 is greater than. Okay, here's a 10. So that's less than. So what we're gonna do, you might think that we would swap them or something. What we're actually gonna do is keep track of how many elements are less than 11. So far it's one element. And then we're just gonna swap 10 and 40. But we're mentally keeping track of, in our code, not mentally, there was one element that is less than 11. Now we keep going. Nope, that's greater than. Okay, here's another element, less than 11. So we do the same thing again, but now we know we have a variable, and we say there are two things less than 11. So once we hit the end, because there's nothing greater than 11, or nothing less than 11 anymore, now we know, okay, there were two things that we added in. There are two items that we now need 11 to leapfrog over. And that's what happens. So now 11 is in the correct spot. So does that make sense? We count 1, 2, and then we move to that position. And now everything on the left side is less than 11. Everything on the right side is greater than 11. Now it happens that these two values are sorted already, but our code doesn't know that. It's not guaranteed. Okay, so now our code is going to take the left side and repeat the same thing. So this is showing us 11 is cemented in place. And now it does the same thing with 6 and 10. But this is super short because there's really no other values to compare. And so it cements 6 and then it cements 10. But now let's focus on the right side. So next up we have 50, and I'm just going to count how many numbers are greater than 50 or how many numbers are less than 50 as we go through. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers. So now we're just going to swap 50 to the end there. Now 50 is in the correct spot, so it should turn orange. Okay, so now we have to sort the left and the right side, but there is no right side, so we have to sort this left side. So we pick 27 again. Not again. We picked 27 for the first time. Now we compare it to 43. That's greater than it. Greater. Okay, here's a less than. So we swap, and we keep track of, okay, there's one element that was less than. Keep going. Here's another swap. Now we have two elements that were less than. Keep going. Now we have three elements that are less than. And finally, four elements. Now where do we put 27? Well, we know that we had four numbers less than 27. So we swap it there. All right. So I'm not going to walk through every other step. I'm just going to fast forward. But you can see 27 is now in correct position. Now we do the left side. Keep going. Now we do the right side. 43 is in the correct spot. Now we have 42 in the correct spot. Okay. And we're almost there. There we go. Fully sorted. So it's kind of, this is why, for me personally, maybe that made more sense to you, but trying to write this in code can be very intimidating. And I'm going to give you the pseudocode in the next video, but it's not at all the expectation that you just go and write it. This is a hard one. So the actual code is not that long either, but just conceptually, it's a lot. So I'm going to give you the pseudocode. If you want to attempt it, go ahead, but also don't beat yourself up, please.